Hi all. Today we will take a look at the filtering operators which are available in Rxjs. So filtering operators basically filters out certain values from an input observable based on some predicate. So let's take a look at one of the most commonly used filtering operators, that is the filter. So here in our playground I have added a sample filter. So basically I have an input source which is an interval which emits a new value every 1 second, and that input observable we are passing as a pipe, and within the pipe operator we have the filter where I am going to select only the even numbers. So that particular condition for selecting the value we can provide within the filter operator. And now when we run our application, you can see that only the even numbers are getting emitted as an output from the filter operator. So this is one of the most commonly used filtering operators in Rxjs. The next operator which we will take a look at is the elementAt operator. So elementAt is similar to the at operator which we have in string. So basically we can provide an index so that value at that particular index alone will be returned from that observable. So here again I am making use of a timer or an interval which emits values at 1 second. I am passing the index as 5 to the elementAt operator. So basically it will return the value which is at the position or at the index 5. So since the index starts from 0, it will be the sixth element from our stream. So it should be 5. So in the playground, when we click on elementAt, you can see that initially no value is emitted, but when the fifth index, that is the sixth value, comes, immediately the value is emitted and input observable is completed. So the next operator is the first operator. So as the name suggests, it basically selects the first value from a source and returns it. So if you go to the playground, when we click on it, you can see that the initial value, that is 0, is emitted and immediately the stream is completed. Now similarly we have the last operator which returns the last value from a input observable. So here we cannot use since it is not a finite observable stream. So here I am making use of the from operator and I am emitting 3 values, 1, 2 and 3. So ideally the value 3 should be returned by the last operator. So when you click on it, you can see that the value 3 is emitted and immediately the stream is completed. Next we have the single operator. The single operator, what it does is it checks for a certain predicate similar to filter, but in case the predicate matches only a single value. So for example, we have a stream here, input stream, which consists of values 1, 2 and 3. And we have the single operator which accepts the predicate like it should return an even number. So currently only 2 is the even number within this list. So what happens is that when you click on single, the value 2 will be emitted and the stream is completed. But suppose there were more than one even number in our input observable. So what happens is that when we click on single, it throws out an error. So basically what it does is it does an assertion that only a single value should be there within our input stream matching the predicate we have provided. But since there are multiple values, it will throw an error, that is the sequence error implementation. So it also says that the message is too many matching values since we have 2 and 4 which are even numbers. The next operator is the ignoreElements operator. So what it does is basically it ignores all the values from the source. So here I have given 3 values. All these will be ignored and the observable stream will be directly completed, and the completion is the only event which you will get. or in case an error occurs in this input observable, we will be receiving the error. But as such, no values will be received from this ignoreElements operator. So here I am going to click the ignoreElements. You can see that no values are emitted, but it is directly completing the input stream. So next we have a set of operators which begin with the name take. So the first operator is the take operator, where we can provide a number as a parameter. So what happens is that in this case we have provided the number as 5. So what happens is that it will take the initial 5 values from the input observable. So let's see what happens. We have a interval which starts from 0. So I am going to click on take. So what happens is that the first 5 values will be emitted by the operator, and once that is done, it will complete the observable. So that is the simple take. Now we have the takeLast, which is similar to take, but it takes the values from the end of the input source. So here again we cannot give an infinite input observable like interval, but instead I have given a finite observable. So I have given the values 1 to 5. So now what happens is that it should ideally take the last two values, that is 4 and 5, since I have given the parameter as 2 in our takeLast. So I'm going to click on the takeLast. You can see that only the last two values are emitted and the input stream is completed. Next we have the takeUntil operator. So this is one operator which we most commonly use in handling subscriptions within our Angular applications. So what the takeUntil does is that the takeUntil operator, it accepts another observable stream as the parameter. So what it does is it keeps on emitting values from a source observable. So in this case, the source observable is an interval which emits a new value at every second. So it keeps on emitting values from this observable unless the notifier is new observable which we pass as the parameter to takeUntil. So until a new value or a single value is emitted from this notifier stream, it keeps on emitting values from the input stream. So in this scenario, what happens is that I have provided the notifier as a timer which starts at 5 seconds and it emits a new value at every 1 second. So here in this scenario, what happens is that the takeUntil will take value from the interval starting from 0 till the 5 seconds has elapsed and a single value is emitted from the notifier. So when that happens, immediately the source observable will be completed. So let's see that. So here I click on the takeUntil. So the value has started emitting, and immediately after 5 seconds, what happens is that the notifier emits its first value. At that time, immediately our input stream is completed. So here you can see that only 4 values got emitted, even though we gave 5 as the starting point. This is because the interval does not immediately emit a value. It emits the value only after the first second. So basically we get 4 values. So the next operator is the takeWhile operator. So this is opposite to what we have the takeUntil. So takeWhile is basically we can provide a predicate. So while that predicate is true, it keeps on taking or emitting the values from the input observable. But once it becomes false, immediately our source will be completed. So here I have given the condition as long as the value emitted from this stream is less than or equal to 5, it will be emitted. But once it's become greater than 5, immediately it will be terminated. So I'm clicking takeWhile. You can see that once the value from the input stream becomes greater than 5, immediately the stream is completed. So next we have a set of operators which starts with the keyword skip. So this is exactly opposite to what we saw till now, that is the take operator. It starts with the basic operator called skip. So what happens in case of skip is that we can pass a parameter which is a number, which tells that we can skip the provided number of items from the input observable. So in this scenario, I have given the parameter as 5. So what happens is that from the input observable, that is interval, it will skip the first 5 values, and after that it will start emitting. So let us click on the skip. You can see that initially no values are emitted until the 5th value is completed. So this is the 6th value since the index starts from 0, and after that it keeps on emitting. So in our case it is infinite input stream, so it will keep on emitting. So the next option is the skipLast. So what it does is that it will exclude the last 2 values from an input stream. So here again I am providing the input stream using the from operator, where I give the values 1 to 5. So it would emit the values 4 and 5. So when I click on the skip last, you can see that the last 2 values are skipped. So next we have the skip until. So again this is similar to the take until, but that's the opposite way. We can provide a notifier as the parameter again. So here we have the input as the interval, and the notifier will be starting emitting after 5 seconds. So in this case what happens is that until the 5th second, no values will be emitted from this input source. But once the 5-second mark is reached, the timer, that's a notifier, emits the first value. Immediately skip until operator starts taking values from the interval and it keeps on emitting. So let's click on that. So now no values are emitted, but when the 5-second is reached and the first value is emitted from the notifier, immediately you can see that it starts emitting the values from the input observable. Now we have the skipWhile. SkipWhile is again similar to takeWhile, but does the opposite. It accepts a predicate. As long as the predicate is true, it will keep on skipping values from the input source. So once the predicate becomes false, then only it will start taking or emitting values from the input observable. So here I have given like when it is less than or equal to 5, skip it. So once the value is greater than 5, then only it will start emitting the value from the input observable. The next 3 operators have the name distinct, or it starts with the name distinct. So the first operator is the distinct operator. So this can be used to get distinct values from a set of values emitted from an input observable. So in this scenario, I have a few numbers which are emitted, and this basically removes the duplicate entries. So in this case, 1 will be emitted, this 2 will be emitted, but the second 2, it won't be emitted because it is not a distinct value. So it will be skipped. Next 3 will be emitted, 4 will be emitted, 5 will be emitted, but this 4 will be skipped since it is already present within the input. So this is the way in which you can call the distinct operator. Now when we click on the distinct, you can see that the values 1, 2, 3, 4, 5 are emitted and all the duplicate entries are skipped. So another format in which you can call the distinct operator is that you can pass a comparator as a parameter to our distinct operator. So previously we had not passed any parameter, but in this scenario what happens is like I have an input which consists of a list of objects which has the name and the property age. So here I need to make it distinct based on the name. So I have given this as the comparator. So now what happens is that all the duplicates with the name. So here we have 2 values or 2 entries with the name as A and 2 entries with name as B. So those will be filtered out. Let's go to the application. When I click on distinct, you can see that only 2 entries are emitted since the distinction is based on the name. So next we have the distinctUntilChanged operator. So the difference between distinct and distinctUntilChanged is that it not only checks for the distinct values but also check whether these distinct or these values are emitted consecutively. So in this case, you can see that first the value 1 is emitted, after that 2 is emitted. So the 2 is different from 1, so it will be emitted. But after that again 2 is emitted. So this will be skipped. So until the new value is different from the previous value, it will be skipped. So 3 will be emitted, 4 will be emitted, 5 will be emitted, and even though 4 is not a new value, that is not a distinct value, but still it will be emitted because it is different from the previous value, which is 5. So this is the way in which you can pass the distinctUntilChanged operator. So when we go to our playground, you can see that this is the output which is emitted. So you can see that the value 4 is repeated even though it is a duplicate. But it is because it is distinct from the previously emitted value. So here again we have a similar option of passing a comparator. So in this case what I am doing is, again we are comparing based on the name, but here you can see that only this particular value will be removed because that is the only entry which has a same name as the previous entry. The A, even though it is duplicate, it is coming after B, so it will be emitted. So let's see that. So here you can see that the value name B and age 3 was skipped since it is coming consecutively as a duplicate. So now we have one more operator called the distinctUntilKeyChanged operator. So here what it does is, instead of having a comparator like this where we provide the key value, that is a name, based on the key name we need to filter out the distinctUntilChanged. But instead of that we can just pass the name of the key based on which you need to do the distinction. So the same thing what we achieved here using this comparator, we can achieve using the distinctUntilKeyChanged and by passing the name of the property, that is name. So in this scenario what happens is this particular entry will be removed. So if we click on this, you can see that the value name B and age 3 has been filtered out. So it is a convenient method. Instead of using the comparator, you can just pass the name of the property. So here again you can make use of a comparator in case you need to add some custom logic. In this scenario what happens is that I am basically trying to check the initial initial character of our name, and in case it is matching, again I want to skip it. So in this scenario what happens is that the value B along with this AA will be skipped since the initial character is same for both these entries. So now you can see that the last entry AA, that was also skipped. So in case of any custom comparison other than based on the key, so here inside the key we are making another comparison. So in such scenarios we can make use of the comparator option within the distinctUntilKeyChanged. So next we will take at 4 timer based events which are quite useful. One is the audit time, other is the debounce time, sample time, and the throttle time. So first let us take a look at the audit time. So here initially we have an input source, that is the document.click, which we get the from event operator. So whenever we click on the document, the click will be the input. Now we have the audit time operator which will accept a parameter, that is the time. So what happens is that whatever time we gave within the audit time, it will be made use as a timer countdown, or timer interval. During that time, any event that comes from within our source observable, the audit time, what it does is that the first time we click on the document, the timer will be started. Then it will wait for the time, that is 3 seconds, and whatever values are emitted from within that observable during this time period, it will take only the last value and emit it when that time period is over. So what happens is that first when we click on the document, the timer starts, then it will collect all the events during that time period, and it will emit the last value which is emitted from the observable, and immediately the timer stops. Then the timer will be restarted only after the new click on the document. So let's see this. So here we have the audit time. So now I have clicked. Now what happens is that the timer started, and after 3 seconds the value is emitted. Since I made only a single click, you can see that that particular event was emitted. Now let's do one thing. Let's make 3 clicks. 1, 2, 3. So now you can see that again after 3 seconds only a single value is emitted, and this was the last value. So you can see that the client X is around 790, which will be around this place, and client Y is also here. So as you can see that only the last value which was coming from the input observable during that time period, that is 3 seconds, the last value was emitted. So similar to this, we have the throttle time. What it does is that instead of emitting the last value, it will immediately emit the first value. So here, once we go to the throttle time, you can see that I clicked, immediately a value is emitted along with the click details. So now let's do one thing. The 3 seconds have elapsed. Now I am going to click here. You can see that immediately the value is emitted, but after that, till the 3 seconds are elapsed, a new value will not be emitted. So once the 3 seconds is elapsed, I click on that, immediately a new value is emitted. So again, when I click, immediately the first value. So what happens is that when I click on the document, the timer starts, and immediately that clicked event, that is the first event, that will be emitted. Then it ignores all the other events from within this input observable for 3 seconds, and then the timer stops. Then what happens that the next click or the next event which comes from this observable, it will be triggering a new timer, and the value of that trigger is immediately emitted. So this is the throttle time. So next we have the sample time. So sample time is similar to the audit time, but the difference is that in case of sample time, the timer, it keeps on repeating every 3 seconds. So it does not start or stop based on any particular event. So initially when we give the sample time, immediately the timer is started, and it collects all the values which are emitted from this particular from event, and it emits the last value. But it does not stop the timer after the 3 seconds are completed. So let's see that. So initially I am clicking on the sample time. So now the timer is going on. So now one particular value is emitted. So the second value is emitted. Now I am going to click here. Again value is emitted. Now I wait again, and when I click, you can see that immediately a new value is emitted. So it keeps on checking for any value within 3 seconds, and it does not stop, or it does not stop the timer. It will keep on repeating the timer every 3 seconds, or the time which we have specified within the sample time. So that's the difference between the audit time and the sample time, even though they are similar in emitting the last value, but the timer concept is different. And finally, we have the debounce time. So this is the most commonly used timing operator which we use in our Angular applications. In case we have a search bar in our application, we usually make use of the debounce time. So debounce time, what it does is we can provide a time within the debounce time operator, and whenever this particular event happens, it starts a timer, and whatever values which are emitted from this observable during that time, it will be ignored. And the thing about debounce time is that whenever a new click is happening within that time, the previous timer is cancelled and a new timer is started. So it keeps on going until no new values emitted from this input stream during that time period. So let's see this in action. So I am clicking on the debounce time. So now I am keeping on clicking on the document. So now you can see that no value will be emitted until this clicking stops on the document. So I am stopping it. So now you can see that after stopping the click event, after 3 seconds, the last value was emitted. So this is the use of a debounce time. So basically, it will prevent too many events or too many inputs streaming from an observable, and once the observable is stable, then that particular stable value alone will be emitted, and in such scenario we will be able to improve the performance of our application, especially in case we are making an API call or something within this observable based on the value. In case there are too many changes, it can affect the performance of our application. Now for these four operators which we saw now, that is the audit time, debounce time, sample time and throttle time, we have a corresponding operator without the time option where we can pass another observable as a parameter. So based on the value emitted from this observable, the sampling will happen. So here in case of audit time, we have audit, and there we can pass something like an interval which repeats itself every 3 seconds. So this is quite similar to the audit time, and the same way we have debounce for the debounce time, sample for the sample time, and throttle for the throttle time. So let's go to the playground and see the audit in action. So here when I click on the document, you can see that the last click event is emitted in the within the 3-second time interval which we gave in our audit operator. Similarly, we have the debounce where as long as I keep on clicking on the particular document within the 3 seconds, it will never emit a value. Once I stop, that last stable value will be emitted. So this is quite similar to our debounce time. And we have the sample where it will keep on sampling the values which are coming. You can see that it is keep on emitting every 3 seconds. And finally we have the throttle. So it's quite similar. Whenever after the input source emits, when I click on the event, click on the document, immediately a value is emitted. And after that, all the values are discarded. And again, after the timer stops, when I click, immediately the first value is emitted. So hope you are able to get a good idea about the different filtering operators available in Rxjs. We will be continuing to explore the different Rxjs operators in coming videos. See you soon. Thank you.